Yes, that's right. We can start now, I think.
All right. Okay. Assalamualaikum warahmatullahi wabarakatuh, and good morning to professors, associate professors, doctors, and ladies and gentlemen. I am Adderley from Faculty of Computer and Mathematical Sciences, UiTM Perlis, specifically from Applied Computing and Technology Research Group, and I am your moderator for today's event. First, I would like to extend our warmest welcome to all of our attendees, both from Malaysia and Indonesia, to our second joint international webinar series on the topic of artificial intelligence and machine learning. For the attendees information, this is our second joint webinar following the first webinar conducted on the topic of software engineering last month. The webinar series is jointly organized by Applied Computing and Technology Research Group, UiTM Perlis branch, and Telkom University Indonesia. So this is our second webinar. It aims to share knowledge, ideas, and skills in artificial intelligence and machine learning. And the participants are expected to be able to learn tips and tricks in these two emerging fields. And today, we have invited 4 expert speakers, both from Malaysia and Indonesia. And each speaker will deliver their respective selected topic. And each delivery will be followed up by a question and answer session, which each speaker has 30 minutes for both delivery and question and answer session, respectively. Now, allow me to welcome and introduce our respective speakers. The first speaker is Dr. Tajul Rosli Razak from UiTM Perlis branch from Malaysia. And then our second speaker is Dr. Warih Maharani from Telkom University, Indonesia. And the third speaker is Dr. Ruhaila Maskat from FSKM, UiTM Malaysia. And our final speaker, the fourth speaker, is Dr. Romadhony from Telkom University, Indonesia. So depending on our expert speakers' availability, they will deliver their content in such arrangement. Now, I think the first speaker is already here. And without further ado, our first speaker, Dr. Tajul Rosli, to deliver his talk. Please welcome.
Assalamualaikum. Ray, can you see the slide?
Yes, Dr. Tajul, you can see it clearly.
All right, so, okay, Assalamualaikum and very good morning to all. All right, so thank you all for joining this second joint international webinar focusing on artificial intelligence and machine learning topics. All right, so let me introduce myself. All right, my name is Tajul Rosli Razak. I am a member of Applied Computing and Technologies RIG UiTM Perlis, Malaysia. So again, thank you for giving me this opportunity to share my little knowledge on this particular topic. So for today's topic, I would like to present about explainable AI, or the short form is XAI. Shall we start now? Okay, this is my presentation outline today. So we'll cover several of topics. Okay, I will start with the introduction, and then I go to the a little bit intro for the artificial intelligence, and then I go to the explainable AI, XAI, and then I will go to the fuzzy system, and then under the fuzzy system, I will explain a bit about interpretable fuzzy system, and I will show some of sample of application, and lastly, I will promote a new task force is under IEEE Computational Intelligence Society on explainable fuzzy system. Okay, before I start, I just want to clarify that this presentation is a very brief, okay, just to introduce, okay, initial presentation on the explainable XAI. Okay, a little bit of background on my education. All right, so I obtained my Bachelor of IT from the University of Malaysia, okay, in Malaysia. And also the same university, I obtained the Master of Science in Intelligence System. And then this year, I successfully obtained my PhD in Computer Science in University of Nottingham, UK. So my PhD title is about towards designing and measuring interpretable hierarchical fuzzy system. So somehow my topic is very related to my PhD area. All right. So and then my research interest is AI, artificial intelligence, and then focusing on the fuzzy logic system, and also on the decision support system. Okay, all right. Okay, so before I proceed with my presentation, let's see the state of the art of the AI, artificial intelligence. Okay, by looking on this picture, all right, yes, you can see that AI is combination between artificial and intelligent. Okay, so by definition, guys, so the AI is intelligent exhibited by machine rather than human or other animals. The field of AI research defines itself as a study of the intelligent agents, any device that perceives its environment and take action that maximizes its chance of success at some goal. So in the easy word, right? So the AI is, they would like to mimic the human intelligence, okay, and then transform into the computer program in order to provide a solution where it's the best like a human decision. All right, so what is AI actually? So AI is using a computer, okay, to solve a problem or make an automated decision. Okay, try to replace what is the task that has been done by the human. So basically, it will require the intelligence, the human intelligence. So AI is a very popular nowadays, okay, in conjunction with the IR 4.0 as well. All right, so it is having applied to the various applications. Okay, as you can see from this picture, so AI is applied in many applications, right? For example, in healthcare, transport, agriculture, education, and etc. Right? So for me as well, I involved with several of the AI projects. Okay, particularly I'm focusing on the fuzzy logic system, hierarchical fuzzy system, expert system, data mining, and decision support system. So what we can offer with the AI project, okay, mainly focusing on the prediction, forecasting, and then also medical diagnosis, recommendation system, decision support system, and intelligence system. So I have several of a publication that are focusing on the AI project that fall under education. This is some of my publication under education area, and also on the medical area. Okay, this is some of publication that involve with the medical area. And also in agriculture, okay, we do have some project with the agriculture, for example, like to do the mango grading using the fuzzy image analysis and so on. And the last one is also with the military, right? Okay, so that is my experience on the AI project, all right? So basically, when we talk about the AI, the artificial intelligence, okay, of course, okay, we would like to focus on the accuracy of system. Okay, let's say if you want to develop an AI project, yes, you want the AI project that has the accurate result. So in order to come out with the accurate, okay, result, so the system, the AI project will become more complex, okay, because the linear regression between the complexity and accuracy is in the linear relationship, right? So in this graph, it shows like the relationship between the accuracy and complexity is a linear relationship. So it increases exponentially together with the complexity. So somehow the AI project mostly is a black box model, which is we are more focusing on the accuracy system. However, a drawback here now, we lose some of a little bit ability to make a system more can do the explainability, right? So I will touch a little bit more on in the next slide. So here now, okay, in our new direction of AI, okay, there are some fundamental challenges in AI, okay. For example here, okay, AI and the machine learning system have to exceed the human performance in nearly every application where they have been tried. Yeah, it shows by the accuracy. You can see that more accurate, okay, like 90%, 95%, 99%. All right. So AI systems are good, yes, definitely, but sometimes make a mistake, and human user will not trust the decision without explanation, because now the AI project is lack of the explanation capability. So the key aspect of the vision of interpretable AI is to have a decision-making model which can be understood by human. Okay, bear in mind that the decision-making system is something that involves with the people. So it will be advantageous if that model can be understood by the human being. So here is the issue is that they have a trade-off, okay, between the AI accuracy and the explainability. All right. So the most accurate method. For example, if we use the CNN, ANN, deep learning, okay. But however, it's the lack of the ability to provide explanation, okay. However, in the other way, if we focus on the understandable method, such as we use the rule-based decision tree, so they will have a drawback on their less of accuracy because they tend to make a simple program. So here is an example that I said about the trade-off, okay. For example, if we use the expert system, as we know, the expert system will involve the expert in their algorithm, in their model. Yes, of course, it will be good for the explanation as we try to make it the system more lively, more human. Okay. However, it's not good for the accuracy. And if we focus more on the accuracy, for example, if we use a deep neural network or neural net, yes, for sure, it's good for the accuracy as being proved. But however, it's a lack of explanation in their model. So the issue now is how can we get both quality in our AI project? So another issue is, okay, when I joined a conference recently, okay, in the IEEE Wiki 2020, I received this picture, okay. Can AI be taught to explain itself? All right. So as a machine learning become more powerful, all right, the field of researchers increasingly find themselves unable to account for their algorithm know or how they know it. All right. Yes, if we can see the black box model, they don't bother about what will happen in the model. They just focusing on the result, on the accuracy, but we never know what will happen inside the box. So now the new features trend, okay, the future direction of AI, how to make it the AI model also can be explainable, okay? Instead of just accuracy, they would like to extend the capability to explain, okay, how the system can be explainable as well. Okay, this is the source that I get the picture, okay? I taken from this article, okay? France Pasquale, 2015, the Black Box Society. So the challenge here is now we would like to transform our black box model to the white box model. So the white box model here we can consider as the explainable AI. As I mentioned before, the black box model, we are focusing more on the accuracy, but somehow it will be lacks of the interpretable or explainability, right? However, in the other ways, okay, in the white box model, it's a simple and somehow it will good on the explainability, but it will be lacks of the accuracy. They have a trade-off between them, all right? So example of a deep learning, example of the black box model, we can say like something like ANN or deep learning. And an explainable AI or white box, for example, we can use the fuzzy system. For example, in the fuzzy system, it's a transparent, so we can see what happened inside the system. So now I would like to go to another direction of AI as I show some of the motivation here. Now I would like to introduce, to explain a little bit brief about the XAI, explainable AI. So a feature of AI system now, there are critical decision is explainability, okay, as I just mentioned before slide, my previous slide. So what is explainability? Okay, we would like to improve in our AI model, okay? We want our model decision that people also should also understand why the automated decision has been made, right? Especially when we involve with the high interaction with the system, such as in the medical decision system and in some knowledge, natural language processing as well, right? So when we're talking about the explainability, okay, explainability is very related to the interpretability, okay? So the word interpretability is a combination between interpret and ability, all right? So the ability is the skill of what, okay, and the interpret is conceived to significance of something. And by dictionary, the interpretability can also be said as capable of being understood, okay? However, the interpretability is somehow very depend on the people background, okay? For example, I myself is a fuzzy guy. So let's say if I looking at the fuzzy model, it will be advantage for me to understand, okay? So it somehow is related to it's depend on the people background as well to help to understand the interpretability. So what is the current state of the art, okay, in the explainable AI, okay? So this is a framework, okay, has been proposed by DARPA, okay, Defense Advanced Research Project Agency in US. Okay, here is the framework on our today in the AI model, for example. Okay, let's say we have a training data image, okay, and then we put the system into the machine learning OAN. So to train, okay, based on the data, and then because the machine learning is very good to adapt with the self-learning. And then when we got the new picture here, okay, a new input, and when we put into the new learning function, and then the system will identify, okay, there is a cat, okay, and very high accuracy. Now it's 93%. However, for end user, they will ask why, how can we get that answer? Okay, so there's some questionable that some of user think it's not fast with this answer, although the accuracy is very high. Okay, there's some question. So why cat? Why not dog? Why not other animal? Okay, there's some argument on the decision. Okay, so the black box statistic prediction are inadequate. Okay, in some way. So now for tomorrow, okay, the new direction now for we would like to make AI is more explainable instead of accuracy, and also want to add another capability is which is explainable. Okay, so the same framework as in previous one, but now okay, looking on the model now, they add another explainable model and also explanation UI, user interface. So now by using the same data training, learning rate, okay, but using the same input we put into the system, but now the system also detect that is the cat, and also they will provide some explanation. Okay, for example, why is a cat? Because it has a fur, whisker, and claws. Okay, it also has this feature of the hair. Right. So look at this. Okay, the system is more like a human. Okay, when you give a reasoning, now they provide some explanation. So the end user, okay, the end user will, okay, now I understand why the system gives the output as a cat because of this explanation. Okay, so now the system is more, the more intelligent, can I say that, all right? Okay, they have the accuracy as well and also can be explainable. Okay, so explanation must be understandable to non-specialists as well, okay? So why we need XAI? Okay, as I said, to justify system decisions so that the human participant can decide to accept them. Because remember, when we make an AI project, okay, we will give the answer, the output, but at the end, the user, the end user will decide whether they want to follow our result or not. So somehow XAI will give some confidence to the participant. And then to explain the system choice to guarantee the safety are met. And then to build the trust in the system choice, especially if a mistake is suspected or the human operator does not have experience with the system. And then to explain the system choice to ensure fair, ethical, legal decisions are met. And lastly, to explain the system choice to better evaluate or debug the system in previously unconsiderable situations. So that's why now we need AI to be explainable as well. So now, when are we talking just now, I said that explainability is very related, very close to the interpretability. All right. So let's say now we have to go to the new direction of AI. Let's say we have a machine learning, for example, in the AI, the current AI system. So machine learning, as we know that the system is very good on the self-adapted to the data. They can learn through the data. However, it's a lack of the explainable. So now we need some of the interpretable system before we go to the explainable AI, okay? Where the interpretable system is the system whose structure, behavior can be understood. Then from that, now we can transform to the XAI model. Okay, the XAI model is the system that capable of answering why question. All right, here is some of the example that I did before this. That I also input some of the explanation before in my previous project. Here in the 2005, okay, I made a system to measure the cadet performance, okay, in order to determine the stage of UiTM publish. Okay, instead of we just give the output, so now we provide another explanation to the system. So the system will be more explainable. All right, instead of we give the result, and then the system also can provide explanation. Another project as well I'm working on, I published in 2013, all right? So it's a medical diagnosis system, okay? The dengue, okay, the dengue is a 1+2 system, all right? So instead of just give the output, all right, we also provide the explanation. So somehow this explanation will educate the end user as well. Okay. The same goes to the next project I made in the 2014. Okay, I made a recommendation system. Okay, recommendation system for the student to choose their career path. So when we give the output, okay, and then because we want to let the user to decide whether they want to accept or not. So when we provide the explanation, okay, they will help the end user to trust with this answer. All right. So I'm going to go to the second part of my presentation. Okay, previously I just give some motivation on the XAI. Now I will go focusing on my my area. Okay, more towards the explainable fuzzy system. So I'm gonna be very quick. Okay, as we know, a fuzzy system will become a popular method as well in order to modeling with the uncertainty and imprecise information. As we living in the real world now, okay, we are living with the uncertainty, a lot of uncertainty as in the real world. So the fuzzy logic system is very good to model the uncertainty. For example, let's say I have a temperature, okay, so the temperature can be modeled through the fuzzy set, okay. Let's say they will class the temperature on the cold, normal, and hot, and so on. So they have some of the method. Okay, we have clear direction. Okay, from fuzzification, fuzzy inference, and de-fuzzification. All right. So fuzzy system can provide a good level of interpretability. They have a key building blocks. Okay, to help. Okay, to help improve the explainable AI. This is due to that fuzzy logic system is a white box model, is a transparent. Okay, it's very simple to understand. All right. And then why is happened? Because the fuzzy logic system apply, okay, a linguistic variable and linguistic rule, okay, in their model, okay, where it's very close to the human nature language. So that's why it's easy to be understandable, right? So there is a linguistic variable here, right? For example, in temperature, for example, in here we convert the here to be in the small linguistic term, small, average, large, and then they have a fuzzy rule, if else, and then they have defuzzification. So they use because of they use this linguistic variable and linguistic rule, it will become more close to the human natural language. Okay, I will touch a bit about the interpretable fuzzy system. Okay, so before we go to the interpretable system, they have two main components here, right? So either you want to focus on the complexity interpretability, okay, or semantic interpretability, right? So if the complexity of the complexity based, so they are focusing more on the number of rules and number of linguistic variables. They have lots, but I would like just explain a bit, okay, because these are just a brief introduction of my presentation. I just want to touch a bit, okay. I will take two components to present. And then the another part component is a semantic interpretability. Semantic is to focus on the meaning of linguistic variable, linguistic term that used in fuzzy system. Okay, here is an example scenario. Okay, let's say I have a iris classification problem. They have 4 inputs: sepal length, sepal width, petal length, and petal width. Okay, and the output of the flower is to identify the iris type, either sentosa, versicolor, and virginica. Okay, so let's say I have 2 models. Okay, model fuzzy A and model fuzzy B. So the model fuzzy A, we have 81 rules. Okay, 81 rules, right? And then the fuzzy model B, they just have a 27 rules. So they will have a less complexity, because the complexity is very related to number of rules. If we have more number of rules, they will become more complex of the system. Okay, if we have less rules, so they will become a less complexity. So if we have 2 models that can come out with the same accuracy, which one do you want to choose? Okay, for me, if we ask me, of course I would choose for the simple one, because using the simple one, I also can produce the same accuracy with the complex one. So it will be more easy to understand if we have less room. Okay, to justify my answer, I made a study, I made a user study. Okay, I bring out to this the iris classification problem. I bring to the conference in Fuzzy IEEE 2017 in Italy. So I bring these 2 systems, A and B. Okay, A system that have 81 rules, and B is the system that just have 27 rules. Okay, yes, although we just use a different fuzzy, because with the B I use the hierarchical fuzzy. So here I just want to show to the output. Okay, I have a 30 participants that answer my questionnaire. So yes, most of them is agree that B is more easy to follow when we have a less rule. Okay, and then when I class into the small one, so it will become a more easy in terms of readability of the rule as well. Okay, so that is to help based on the complexity based interpretability. All right. So another component is a semantic interpretability. All right. So for example here, I have two rules. Okay, rule number 1 and rule number 2. Rule number 1, I use if sepal length is small and sepal width is small, then the sepal is small. All right. So I use a very understandable of the rule term. Linguistic term. However, if I use a rule 2, let's say if X is S and Y is S and then Z is S. So it's still arguable here is what is X, what is Y, what is Z. So if we have two rules, rule 1 and rule 2, which one is easy to understand? Okay. Of course, if I ask people as well, they will say rule 1. In fact, if they don't have any background on the fuzzy, for example, but if we show the rule to them, okay, because the rule is like a close to the human language, so they become easy to understand. So that's why we have to use the very proper linguistic term, okay, to increase their semantic interpretability. All right. So now the challenge is how to build the interpretable fuzzy system. Okay, it's still under discussion now, right? It's still have a debate how to produce, how to come up with the interpretable, because it somehow is related to how people perceive the interpretability is based on the people perception, people background. Okay, so how interpretable, the challenge here is how interpretable fuzzy system can be created, and then how interpretable fuzzy system may pave to help to improve the XAI, explainable AI. Okay, so I have conducted initial works, okay, during my PhD study. Okay, so before I start, I have to go to the ground, okay, to study state of the art, okay, of the interpretability. All right, so now I propose a measure, okay, because in order to classify the system interpretable, we need to have a measure indicator to say the system is interpretable. So I propose here in the paper I presented in Fuzzy Article 2017. And then because of the interpretability as well is based on people perception and people background. So I also conduct a study, and then I ask them, and then I publish in IEEE Symposium Series of Computational Intelligence in 2008 in India. All right. And then from the people input, I incorporate them, and then I propose a new measure on the interpretability using the participatory design approach. Okay, this one is published in the IEEE Transaction Fuzzy System in 2020. Okay, and then they have another component that we need to know. Okay, so that is a complexity. Okay, so now I study about the interpretability. I also study about the complexity. So I propose a new measure of complexity in the fuzzy system. Okay, when I have both quality, interpretability and also complexity, now I will come out with a model how to we design interpretable hierarchical fuzzy system. Okay, we try to apply for the medical application. Now it's still in under preparation. Okay. Okay, so I think that is basically the content of my presentation. Okay, I just want to go brief. I want to go to touch a little bit about this interpretability, explainable, right? Here, I would like to promote, okay, IEEE-CIS Computational Intelligence Society Task Force on the Explainable Fuzzy System. Okay, so you can scan this QR code. Okay, you can go to this website. Okay, so let me explain a bit. Okay, this task force is belong to IEEE Computational Intelligence Society. I am a member of this task force. So this task force is aimed to lead the development of new generation of explainable AI. So in this task force, all right, so you can find out all the activity related to the explainable fuzzy system. We can see what is the activity, okay, what is the new journal that we are released, what is the activity. For example, we did the tutorial in the recently conference in Wiki 2020. So a lot of activity we like to promote, okay, to educate, to explain to end user how can we provide the explainable fuzzy system, and consequently can improve the explainable XAI. All right. So basically, my contents of the presentation is basically much more from these two articles here. First one is from Jose Alonso and the gangs. Okay, they have they propose the tutorial on paving the way from interpretable file system to explainable AI. All right. They presented in Wiki 2020. And the second one is Jonathan Garibaldi, my supervisor. So they presented in the wiki as well. And then all of them is the member of this fuzzy task force of explainable fuzzy system. Okay. All right. So I think that's all for my presentation. I think thank you very much for all to listen my presentation. So this is my contact. Okay, if we want to contact me, okay, maybe we can collaborate in future. Maybe we can discuss, because in this direction, okay, in this research, we still can do a lot of things because it's a very new direction of AI. Okay, I think that's all of my presentation. Thank you very much. So over to you, Mr. Wei.
All right, thank you very much for the talk, Dr. Tajul. A very informative and useful talk. And now we'll begin our question and answer session for the first speaker. So if there is any question, you may turn on your microphone to ask, or just type in your question on our chat box. Probably you can stop sharing right now.
Mr. Wei, how to stop the sharing?
It's a little button below.
Okay, all right, thank you. I have it.
All right, so still waiting for question. You can ask directly by unmuting your mic, or you can type in on the chat box. So while waiting for the question, probably there's one question from me. So I think for the topics that you have just presented just now, Doctor, it involves a lot of programming, right? Where probably there is several programming language that we can use in achieving the project, some of the project that you have done previously. So is there any recommendation of programming languages that we can use in order to develop the project that we have done before?
Okay, thank you very much, Mr. Wei. Okay, thank you for the question. Okay, actually, if you go to the website, the task force of explainable fuzzy system, we do provide the software as well. Okay, we do provide the software how to develop the explainable fuzzy system, but also how to develop the explainable AI. Okay, we do have the software, we do have a system how to develop. Okay, the concept of programming as well, Mr. Ray. Okay, if you see here, the programming, if we have a long code, okay, they will be more complex. Okay, but somehow we can transform to make it shortens of the programming. Let's say we use the library, we use the function, so then we shorten the code. Okay, we just call everything at the end. So the main programming, the main code will be easy to follow if we. No, if that is how we can be applied to the programming. Okay, but if you ask me what is the programming, I may recommend you can go to the website. They have several of the software we listed in there. Software, okay, under task force of explainable AI.
Right, thank you for the answer, Dr. Tajul, which is basically means that there's a lot of library that we can use in order to support the development of the projects, right? So we have two questions from our attendees in the chat box. The first question is from Zayan Zafira. What's the difference between AI and ML? Can you answer that first, Doctor?
Okay, thank you for that question. So I would like to answer this one. Okay, so AI and machine learning. Okay, if we look at on this, okay, this based on my understanding. All right. So the ML is also under AI. All right. So actually, the AI under AI, okay, they do have a lot of the algorithm. For example, machine learning, quantitative system, okay, natural learning, processing, and so on. So if you ask me what is the difference between AI and machine learning system, so the AI and machine learning, sorry, the machine learning is under AI branch. Did it answer the question, Zayan Safira?
Is it answering the question, Zayan? Probably yes. Right, so I think we can take a look at the, yes, Zayan said yes. Okay, so let's take a look at the second question. This is already been asked this now. What is the programming language, most popular programming language that is used in AI?
Okay, okay, thank you for that question as well. So I try to answer based on my my area, right? For example, if I want to do a fuzzy system, okay, I would like to do a fuzzy system. Nowadays, they have a lot of software that available, okay? For example, you don't need to write from the scratch. Okay, you do have this programming that available in the market now. For example, you can use a simple MATLAB that you have a fuzzy logic toolbox, and then you can use also R. Okay, in fact, I and my supervisor we developed a toolbox in R in order to help people to easily create the fuzzy system. So I just talking about on my perspective because I'm more towards the fuzzy, okay, instead of the machine learning and everything. All right. So yes, in fact, machine learning as well. You can do the machine learning using the MATLAB, using R, using Python, and so on. They already have the library. Okay.
Right, so I hope the answer from Dr. Tajul is answered the question from Shaura, right? Okay, I think that's it for our question and answer session for the first speaker. Thank you very much, Doctor.
All right. Thank you very much.
Wasting any time, let's proceed to our next speaker, Dr. Warih Maharani, to deliver her talk on her selected topic. Please welcome, Doctor.
Okay, thank you. I will share my slide. Can you see my slide, Mr. Ray?
Yes, Doctor, we can see it clearly.
Okay, good morning, everyone. Thank you for this opportunity, and let me thank you all for joining here today. My name is Warih Maharani. I'm from Telkom University, Indonesia. As you can see on the screen, my topic today is about introduction of sentiment analysis. Okay, first of all, let's take a look at just how popular social media is based on this number. As July 2020, more than half of people on Earth use social media. These statistics show that 3.96 billion people use social media today. It's equal to almost 51% of the total global population on Earth. Would imply that means that more people use social media than do not. Okay, maybe COVID-19 may have played a role in this statistic. Okay, so based on this statistic, more than 80 people said that digital technology have helped them cope during this pandemic, enabling them to support their children education, stay in touch with friends and family, or maybe to improve their mental health and well-being. And in your opinion, what is the most downloaded social media application now in 2020? Is it Instagram, Facebook? Based on this statistic, TikTok is the most downloaded application for January 2020. Okay, so what is sentiment analysis? Okay, the key aspect of sentiment analysis is to analyze text to understand the opinion expressed by the text. Generally, we quantify the sentiment into positive, neutral, or negative value. It's called polarity. For example, we can see in these reviews, they share their opinion about the food. The first sentence, they express positive polarity or positive opinions about the food, and then the second sentence, we classify the sentence into neutral polarity because they express actual information, and in the third sentence, they express their disappointment about the food. But now, they go deeply trying to predict the emotion from social media. With emotion recognition, we can get more granular data. And it classifies the text into categories representing the human emotions, such as emotional states, good, well, sad, angry. Okay. In 1980, Robert Plutnik created a new concept of emotion. It's called wheel of emotion, because it demonstrated how different emotion can blend into one another and create new emotion. As you can see here, first he suggested 8 primary bipolar emotion: trust versus disgust, fear versus anger, surprise versus anticipation, and joy versus sadness. And then he identified more advanced emotion based on their differences in intensity. As you can see in the diagram, how each emotion relates to the other. Okay, now let's start by looking at this sample. As you can see here, I take an amazing place in Bandung from House Bandung as an example. It's a popular destination in Bandung. It has 4 stars of 5. And then there were 1,052 reviews from travelers. And this is a sample from Kili Fuji. He gave 3 stars of 5. Okay. TripAdvisor performed some tasks and produced an overall rating from travel reviews. And we can filter it based on travel rating or traveler types, years, or language. This is another example of tweet sentiment visualization application. As you can see here, I use keyword corona, and this is the visualization. The sentiment tab visualize the tweet, lie in the emotion scatter plot with pleasure and unpleasant. And then this is the tag cloud that visualize the most frequently occurring terms. The size, so how often it occurs overall the tweet. Larger terms occur more frequently. And the next, the tweet tab shows the date, the user, and the body of its tweet, as well as its overall pleasure. And this is another example of social media analytics in Indonesia. They analyzed tweets and they concluded that the number of galau tweets in 3 months equal to total of population in Jakarta. What is the most galau time? Okay, based on their analysis, this is the most galau time, which is around 9 p.m. and 10 p.m. And girls are most galau than boys, and mostly because of love. Okay, now let's go back to what we were discussing earlier. What is sentiment analysis? From this review, we can identify that this review talk about a place which is from House Lembang. And in this review, we have several aspects. This is the several aspects in the review, and we have several positive term or positive sentiment and negative sentiment. So from this review, we have a list of entities, and then aspect, a list of aspect, a list of sentiment word. So all of them represent opinion quintuple, which consists of entity, which is from House Lembang, and then there are aspects, a list of aspect, and there are a list of sentiment, and Kili Fuji is the opinion holder, a person who write the review, and this is the time. So this is the definition of opinion. Opinion is a quintuple consists of entity, aspect, sentiment, opinion holder, and times. So there are several point of views. Basic test of sentiment analysis is classifying a given text into positive and negative polarity. And more complex, it summarizes and visualizes the polarity based on its aspect or its feature or its rating. And then More advanced, beyond the polarity, we can detect the target, the source, or the complex attitude types, such as emotional states. For example, we try to identify the emotional state, good, well, angry, or sad. So why do we need sentiment analysis? Okay, management thinker Peter Drucker said that you can't manage what you can't measure. He means that you can't know whether or not you are successful until success is defined and tracked, as well as in social media. If you can't measure it, you can't improve it. Okay. And we know that the majority of word data is unstructured. Huge volume of data, such as email, photos, video, chat, conversation is created every day, but it's hard to analyze and understanding. Even if you can, it will require large resources, very time consuming and expensive. So the challenge is how to provide information that delivers only for the business need. Sentiment analysis, however, help business to analyze this unstructured text by automatically processing it. So, why do we need sentiment analysis? Knowing how customers feel about a product is a key to excellent customer services. So sentiment analysis is important to enhance services and then to improve product and services, to determine customer segment, to optimize marketing strategy, or to monitor brand reputation, or maybe to track sentiment over time because sentiment changes over time, and then to discover and update trend and issue around industry. Next, how to perform sentiment analysis. How sentiment analysis work? Okay, now a basic task in sentiment analysis is to classifying the polarity into positive, negative, or neutral. It has many levels of granularity, depending on whether the target is a document or sentences, or maybe a list of aspects, or we can call it fine-grained level. So the first task in sentiment analysis is to perform extraction process. We try to identify or to extract opinion quintuple. As you can see here in the example, we can identify that the entity is from farmhouse Lembang, and then the aspect is the team, and we have positive term, fun, and good. And then the next task is subjectivity classification, which identify whether a text is subjective or objective. Objective is objective sentence express some factual information. For example, I returned the phone yesterday. Okay, we can see that this sentence express fact about the phone return. And then the subjective sentence express some personal feelings or belief. Okay, and then the next text is sentiment classification, which classify the sentence or the document or the aspect into positive, negative, or neutral. And the next task is summarization and visualization, that it will summarize and visualize the polarity based on aspect or based on its rating. And the other task is opinion spam detection. Opinion spam detection, identifying the paid or biased reviewer that write fake review or unjustly promote or demote a review. Okay, now we will talk about the methods. As I said in the previous slide, we can analyze sentiment in fine-grained level, sentence level, and document level. Okay. There are 4 approaches in sentiment analysis. The simple method is a rule-based method. Okay. Although it's simple, it's a very simple method, but it has many drawbacks. It must contain a rule for every word combination in its sentiment library. So creating and maintaining this rule is quite expensive and time consuming. And in the end, these are still any rule conflict and have ambiguity problem. The second approach is a learning-based approach. We can analyze sentiment by using machine learning or deep learning. There are a number of techniques and complex algorithms used to perform sentiment analysis. There are pros and cons each, but used together, maybe they can provide exceptional result. In the last 5 years, researchers proved that deep learning is outperform machine learning. Okay, they proved that because there is no feature engineering in deep learning, but the cons is about the execution time, and it needs very large data. Deep learning takes more time to train. And then the next approach is lexicon-based approach, which calculate the orientation of sentiment by using sentiment lexicon. These are several examples of sentiment lexicon that we can use. For example, LIWC or Linguistic Inquiry and Word Count. And then there are MPKA, SentiWordNet, General Inquirer, or Bing Liu lexicon. You can utilize this lexicon, sentiment lexicon, to classify the sentence or the document or the aspect of review. And the last approach is the hybrid approach, which combine 2 or more approaches. For example, Paramita in August 2020 combine between deep learning method and rule-based method. And then Prerna combine the rule-based approach with the supervised learning. So how it works in simplest term? In simplest term, algorithms scan keyword to categorize text as a negative or positive based on sentiment lexicon. For example, I have a sentence, the quality is bad. After we process the sentence through tokenization, post-tagging, subword removal, we have term quality as a noun and bad as an adjective. Then we will calculate the polarity of this word based on sentiment lexicon. I use SentiWordNet as the sentiment lexicon, and then we can conclude it that the polarity of this sentence is negative. And the other simple method is a rule-based sentiment analysis. The task consists of preprocessing, extraction, and classification. We extract the aspect and in a sentiment by using several handcraft rules. For example, I use a handcraft rule based on dependency relation. And then based on this rule, we have sentiment is positive from this example. And then the next approach is deep learning or learning-based approach. In learning-based approach, the differences between machine learning and deep learning is about the feature engineering. While in machine learning, we need human expert effort to define a set of features to represent the data. There is no feature engineering involved in deep learning. The system learn the best representation of the data by itself to produce the most accurate result. There are 3 popular deep learning frameworks that you can use to perform sentiment analysis. You can use TensorFlow by Google, or maybe you can use Keras or PyTorch to implement deep learning to classify the sentiment. Okay, and now let's move on to the challenges in sentiment analysis. Okay, and the first challenge is about dealing with the context and open domain. One of the problem about context is changes in polarity. This is an example responses to a survey. Imagine the response come from answer to the question, why did you like about the event? Okay, the first response will be positive and the second response will be negative, okay, right? Okay. What about, imagine that the response come from answer to the question to the second question, what did you dislike about the event? Okay. The negative in the question will make sentiment analysis change altogether. So we need a good deal of pre-process or post-process if we want to solve about this problem. However, it's not easy to pre-process or post-process data to capture the context. Okay, so because word polarity varies in different domains, it is impossible to develop a universal opinion lexicon that has a polarity for every word. For example, in the first sentence, the word polarity of the story is unpredictable is positive, while in the second word, the same word polarity of unpredictable is negative because it's depend on its context. Now, the next challenges is about irony and sarcasm. When it comes to irony and sarcasm, people express the negative sentiment by using positive words, which can be difficult for machine or maybe for human to detect without having a good understanding of the context or the situation or the environment. In 2017, researchers from Stanford University published an interesting paper. Having 2 hours to write a paper is one, detecting sarcasm in numerical portion of text. They talk about another type of sarcasm. It's called numerical sarcasm. The idea is related the changes in numerical value, which then affect the text polarity. They implement 3 approaches, rule-based, machine learning, and deep learning. And they prove that deep learning by using CNN produce the best accuracy to classify the sentiment. Okay, and then we know that social data contains a lot of noise, okay, such as irrelevant conversation or content. In this example, we can see that either fat hands and short fingers are not subjective sentence in domain photography because it's talk about a part of body, not related with photography. Especially if we look at Twitter data, which usually affected by noise nature, such as abbreviation or irregular form of tweet. This is a sample of noisy tweets in Malay, okay? And then the other one is noisy tweet in English. So we have so many irregular form or abbreviation that we have to handle it before we process or before we classify the sentiment. Now, the next challenge is how to treat comparison in sentiment analysis. The first comparison, the first sentence doesn't need any contextual clues because it's clear that the first sentence is positive. What about the second and the third sentence? Because context can make a difference. These are also another example of complex comparison sentences. How we can solve these complex sentences so we can classify each sentence into positive, negative, or neutral. And then the next one, how dealing with emojis. Okay, there are 2 types of emoji. I take from paper from Guibon, from emojis to sentiment analysis. There are 2 types of emojis. Okay. There are Western emojis, which consist of 1 or 2 characters. And then there are Eastern emoji, which have a longer combination of characters. Because emoji play an important role in sentiment of text, particularly in Twitter. So how we can deal or how we can solve this kind of tweet, or maybe this kind of tweet which consists only emoji in its tweets. Okay, the last one is now how the new direction of sentiment analysis research. Based on paper of Poria, current challenges and new direction in sentiment analysis research, there are several applications and possible new direction. The red bars represent the popularity of each application, and then the length of the bar are proportional to the publication count in Google Scholar. So there are opportunity for us to perform this task. Okay, so that an overview of sentiment analysis. Thank you for listening. Thank you, Mr. Ray.
All right, thank you very much, Warih. Very informative talk that introduces us to the basics of sentiment analysis. So I think we can proceed to the question and answer session for the topic. So as usual, you can ask questions by unmuting your mic, or you can type your question on the chat box. So I think there is already two questions in the chat box now. So can I read it for you, Dr. Warih? Is it necessary for me to read it to you, or you want to read it by yourself?
No, I get it from the chat. Okay, the first question is for Muhammad Amin. May I ask, what are the best supervised learning algorithm for sentiment analysis? Generally, we cannot make one method is the best for any domains. It depends on the data set or the domain that we want to classify. Majority researchers produce the best accuracy by using such as SVM for supervised learning. And then you can also use deep learning to enhance your accuracy. Okay. That is my answer for Muhammad Amin. Sorry. And then the second question is for Safikah Aminuddin. What kind of algorithm that being used for sentiment analysis? As I explained in my slides, you can use many kind of algorithm, including rule-based learning, and then you can use only by using sentiment lexicon, or algorithm you can use machine learning, such as in supervised learning, semi-supervised learning, or unsupervised learning. In supervised learning, you can choose between maybe naive Bayes, SVM, and then decision tree algorithm. In unsupervised, you can use many kind of clustering method. And then in deep learning, maybe the trend now is you can use BERT or Roberta or LM BERT. You can use so many kind of algorithm. And there are so many libraries that can use to implement sentiment analysis. Okay, and then the third question.
I think you can go to the fourth question, since the third question is somewhat similar to the second one, Doctor.
Yes, the fourth one is almost similar based on the research how accurate the sentiment analysis. Generally, we can make a general conclusion for all the aspect or all the domain. So mostly researcher produce accuracy is about 60 until 90% based on each data set that they use. From
All right, so we have another lengthy question right here.
Okay, it's a long text. How to distinguish whether a sentiment is actually positive or not? Example, a video on YouTube, there are someone who cover a song that someone comment, you have a hidden talent for being. Okay, okay. As I said in my slide, irony and sarcasm is another challenge. It's one of challenges in sentiment analysis. It's kindly hard to solve this challenge, how to classify the irony or sarcasm, because people usually represent the negative sentence with positive term or vice versa, or they represent positive with negative term. So now researchers still work on these challenges, how to perform or how to solve the irony or sarcasm. Maybe maybe there's a factor that will affect the accuracy. It depends on the annotation, the data set annotation. If we have a good annotation or good data set with a good annotation, we can try to make the machine learn. Okay. Maybe that's the answer for Govinda Karisma Dewa. I hope I can answer the question.
Dr. Warih, I
Yes.
have one question.
Yes.
Okay, I just wonder, do we have an automated tool for sentiment analysis, to do sentiment analysis?
There is so much of tool, free or paid. We can use so many tools. If you
for beginner, what is your suggestion?
if you want to code by yourself, you can use library in NLTK using Python. By using Python, there are so many library in NLTK, including natural language processing tools. You can easily implement it by using it.
All right, thank you.
All right, thank you, Dr. Warih. So I think that's all the time that we have for question and answer session for our second speaker. So I think we can proceed to the next talk by Dr. Ruhaila Maskat from FSKM UiTM Shah on her selected topic. Please welcome, Doctor.
Hi. Okay, can you please allow me to share my screen?
Probably Dr. Warih need to make Dr. Ruhaila as a co-host first. And before that, I would like to remind everyone that we have already delayed our event by 20 minutes. So it is probable that we will extend our event till 1 p.m. later. So I hope you guys will be here until the end of our event. Thank you very much. So you may start, Doctor. We can already see your slide right here.
Okay. Right. So Assalamualaikum. Good afternoon, I think. Yeah. To everyone, I am Ruhaila Maskat, okay, from UiTM Shah Malaysia. I'm going to be covering this general topic about machine learning and how it works. Okay. So a bit about me. My bachelor is in IT from UUM, University Utara Malaysia. My master's was in software engineering from University Putra Malaysia. And my PhD is in computer science from University of Manchester, UK. And I'm also a certified Dell EMC Data Science Associate. Okay, so my current research work is on depression, anxiety, and stress. Okay, so this is under mental health. So the title of my research grant that I received is CHARI, okay, a model for proactively detecting candidates, okay, of depression, anxiety, and stress based on MDAS 42 scale in social media. So we're using Facebook groups, okay, in order to garner information or text from these people who are depressed, anxious, or stressed. I'm working with Professor Ramli Musa, who is a psychiatrist in International Islamic University of Malaysia. And I'm also working on automatic labeling of large data sets, okay, because we'll see why it's important. And I'm also working on Malay short text on cyberbullying and scamming at the moment. So what is the difference, okay, between a human baby and a robot baby, okay? So basically, there's not much difference between the both of them because both need to be taught, okay? Both of them need to be taught, or rather they need to be trained, okay? Need to be trained. So if let's say you have a baby human and then you kind of like train or taught this baby human, okay? To ensure it that, okay, these are sweets, these are candies, yeah? So this baby is really going to really just know candies. So whenever you show these candies, it will be able to identify these candies. So the more candies, okay, that you show or you train or you taught this baby, the more is going to be an expert in candies, okay, in candies. So finally, you would have a baby that knows, that can differentiate between candies and non-candies. So this is the underlying concept of classification in machine learning. When you want to classify a certain record, okay, or a certain text or a certain image to be either one class or the other. You can also have, okay, more than one class. More than two classes, okay? Be it, for example, male, female, others, Malay, Chinese, you know, Indian, others. So you can have multi-labels. So they call it multi-class or multi-labels. So if you were to replace the human baby with a robot baby, okay, a robot baby, so the same output is expected. It means that the more you teach a machine, okay, or a robot baby, a machine, the different sorts of candies or any items that you want it to identify, the smarter it's going to become. So in other words, it goes back to having a large data set, okay, specifically a large training set, because you need to have it to be able to identify. So the specialty about training sets is that each and one of the records or the items are labeled, okay? So the machine or the baby will be able to identify clearly, all right, what is this item about? Of course, after that, just like us, once we have been taught or we have taught a machine, we want to be able to evaluate it. Okay, we want to know, has it learned anything? Was it able to just learn the things that we taught, or was it able to also identify similar things to what we have taught, but has not seen before? Okay, so the evaluation process, okay, starts with having bad positives and harmless negatives. So what is these positives and negatives? This is crucial, okay, because the positives are classes or records that is interesting to us. So usually it is of a bad nature. Okay, like for example, if you're doing a fraud detection, you want to know about fraud, and fraud is not something that is good, it is bad. So the positive class is always the class that we are interested to know about. So if, for example, if you're trying to predict, let's say cancer, so cancer itself is going to be our positive class. So how do we evaluate? The easiest way to evaluate is by a formula or a measurement called accuracy. Okay, so you want to be able to calculate, okay, the true positives, true negatives, false positives, and false negatives of each and one of the data set that you want the machine, okay, or the robot baby to identify. So here you have true positives, which means that it is truly positive. It means that we predict it to be true, or the robot or the machine predicted it to be true, and it is actually true. So where does this actual comes from? It comes from the labels from our training set. So hence, again, a point to remember, the correctness of a training set is very, very critical. If you have a wrong or mislabeled training set, that is going to be a very, very tragic, okay? Because the result is going to be unreliable. Okay, and then you have true negatives, which is the predicted, you know, we predict it to be false and it's actually false. And false positive is where the incorrectness of our prediction comes in. Okay, because we predict it to be true, however, actually it is false. Same goes with false negatives, okay? We predict it to be false, but it's actually true. So here we have something called the confusion matrix. It is quite confusing actually, okay, for newbies, all right? So it's called the confusion matrix. So we have this matrix on the y-axis, we have the predicted, and the x-axis, the actual, which is from our labeled data. Okay, so here we put, or we calculate the number of true positives, true negatives, the correct ones, okay, the correct predictions, okay, and also our incorrect predictions. So we use, okay, we use this formula over here, okay, in order to calculate the accuracy. In other words, we want to know how many that we got our prediction correct and how many is it that we got it incorrectly. So then we will be able to know what is wrong with, you know, has our machine learned anything? Is it because of our training set that is incorrect, or is it because of the machine learning algorithm that is quite weak? Okay, so machine learning, okay, under machine learning, you can actually categorize it into two. All right, the ones that has a training set or that is labeled, it goes under supervised learning. So you have classification and regression under there. So there's a few interesting areas or domains that you may want to consider doing for your work or for your FYP or for your project, okay? So for under classification, you have customer retention, diagnostics, fraud detection, image classification, okay? And under regression, you have advertising, popularity prediction, weather forecasting, market forecasting, estimating life expectancy, and population growth prediction. So if you notice, there is a difference between the classification and the regression, because when you look closely under regression, most of the output or the expected results are in numeric. So anything that you want to predict that's numeric should use under regression type of supervised learning. Okay. The classification should be reserved for textual, okay, for textual type of items, okay. For example, the most famous prediction of avocado price, okay, that's one of the most famous kind of cases. So that should go under regression, okay. You should use regression. Okay. The opposite of supervised learning here would be unsupervised learning. So I think you can guess by now, right? If supervised is using training set and labeled data, unsupervised learning would mean it does not have any training, okay, it does not have any labels. So under here, you will be able to find, okay, clustering types of machine learning algorithm, okay, as well as dimensionality reduction. So clustering is quite useful whenever you have data that you just cannot find anyone to label, or it's just not possible to label, okay? So the domains, okay, would mean under this are like customer segmentation, okay, targeted marketing, and also you have the recommender systems under here. And for dimensionality reduction, okay, we have feature elicitation, pretty much under feature extraction or feature selection, okay, and then you have big data visualization, and you have meaningful compression and structure discovery. Okay, so the challenges in machine learning, all right? Most of the challenges goes under, for example, the first thing is that you just don't have any training set. That is very, very difficult, okay? Because you just don't have people that can label, that you can trust, okay? That can actually label your training set, okay? And you have large training sets. So with this big data, you have all the volume, okay, the 3 V's, the volume, the veracity, and the velocity, okay? So you have a lot of data that comes in quite fast, okay? And you just cannot able to have a human labeler, okay, to manually label the training set. So if let's say you have 1 terabyte of records, how many can you actually label? And with supervised learning, okay, you need a good training set, okay, with and it has to be the larger that you have the training set, the better that the machine learning algorithm is going to learn. So here is where the research area of automatic labeling comes in. All right. It is quite an interesting area if you like this, if you find it interesting. Okay, with automatic labeling, you will need to have side information, okay, extra information from the data set itself in order to guess, okay, in order to guess which of the text or the record is under which class. Okay, so that is a possible research area for the problem of large training set. And then you have also unreliable labeling. Okay, this happens when, for example, you're using foreign people to label your training set. For example, in English, okay, back in Manchester, they used to use students to label data sets. And these students are usually foreigners. So when we, even though we can speak English, but we are not native speakers, so there are phrases that may be impossible for us to know the actual meaning of the semantic. So unreliable labeling is also a challenge, okay, in machine learning. And the next one is imbalanced training set. Okay, so if you notice, if you remember, okay, we had bad positives and true negative and good negatives. Yeah. Okay, so the bad positives, like for example, let's take a look at cancer. Okay, or fraud. The number of people that does fraud or has cancer is much smaller than the number of people that does not. And this means that the bad positives, okay, is going to be smaller in number compared to the good negatives. So we have a lot of examples of good, okay, of non-cancer to teach our robot baby. But we don't have, okay, enough cancer cases or fraud cases to teach our robot baby enough for it to be able to identify all sorts of frauds or all sorts of cancer. Okay, it relies on us to feed it. Okay, just like a human baby. Okay, so an imbalanced training set is quite a problem. Okay, it will even skew the accuracy. All right, and there are strategies to overcome this, but they are still working on a better one, since sometimes the imbalanced training set can be very small, like about 1% or 2% compared to the negatives, okay, the good negatives. Okay, the next one is about selecting significant or informative features. This is under feature selection, okay. Like for example, like Dr. Warih mentioned just now, under unstructured data, when you put structure into it, okay, you will have the problem of high dimensionality, because each and one of the words that's within that text is going to become a dimension, it's going to be converted. So you will need to be able to find, okay, to select features that are significant or informative for the robot baby. If not, the robot baby is, you're going to spend a lot of time running the whole thing and on information that is not useful for the robot baby. The next one is ethical issues. Okay, this one, when you deal with human beings, like for example, in my area, depression, anxiety, and stress, we need to consider ethical issues. Okay, and due to this, we are having a challenge to collect data, especially from social media, because most people, I don't know in other places, okay, but most people here in Malaysia, they are quite sensitive when it comes to mental issues, okay, mental health. There is a taboo that people still misunderstand mental health is something to do with being insane, okay, insanity, but it has nothing to do with that. It is different. It is just about mental situation, okay. So due to that, ethical issues can be challenging when you're trying to collect training set, okay, for machine learning. And then after that is unstructured data. Okay, I've mentioned this just now, that if let's say you take social media data, or you take documents of people, or even if you just simply WhatsApp messages, they are unstructured data, and you will still need to tokenize them, and therefore you have a pre-processing phase that is much longer compared to if you use structured data, because structured data is already in columns and rows, okay, especially columns, all right, and you don't need to do anything to it other than just simply do feature selection. Okay, and lastly, okay, the challenge is a powerful infrastructure. You need to have a very powerful in-memory appliance, okay, like for example SAP HANA, which is able to have a very large in-memory, because you have to remember that when you are trying to do the so-called processing, okay, the analytics of it, you will need to have all of the data inside the memory all at once. Okay, so that's from me. You can reach me at my YouTube or Facebook or my email. Okay, and I'm open to any questions.
All right, thank you, Dr. Ruhaila, for the interesting talk about machine learning. So now it's time for the question and answer session for our third speaker. So if there is anyone that wants to ask a question, you can directly unmute your mic, ask directly, or type in the chat box. Right, so there's one question.
Yeah, okay, Assalamualaikum, Doctor. Okay, I'm Ani Afika from UiTM Perlis. I would like to ask you a question. Okay, so in YouTube, I noticed that the subtitle is generated automatically and mostly accurate if the pronunciation is clear in English. So, I would like to know what is the machine learning technique used to generate this automated subtitle? Thank you.
Okay, so there's something called speech to text as well as text to speech. Okay, so you have this area where you convert, okay, from speech to text. So if you notice, sometimes what is being mentioned inside the video on YouTube is converted into textual I think at the it's not at the comments, but at the information section, I think. So there's something called a speech to text. So it's merely just converting what the audio into textual. Did I get your question right?
Yes.
Okay.
Yeah, thank you, Doctor.
Welcome. Any other
All right.
question?
Yes,
So,
can I ask a question?
Yes, of course.
Okay. Sorry, I cannot turn on my video for now. Assalamualaikum, Ms. Ruhaila. I'm Sari. I'm from Indonesia, from IPB University. The unique thing about machine learning is with the big data for the learning phase, right? And I wonder if we are building a new machine learning, we using neural network or fuzzy, where we don't have big data already because the lack of research in this specific topic that we are building machine learning of. How do you suggest that how do you suggest we generate data for the big data for the training phase for the labeling and everything? Can you get my question?
Okay, I think so. The question is about how to get a quality training set, yes?
Yes.
For machine learning.
Mm-hmm.
Okay, so
Yes.
that is indeed a tricky question, and it is still being researched. Okay, one of the ways is that the most conventional is to extract. Okay, is to extract the data by using web scraping if the information is online and it is publicly available. So you need to scrape it. There's no other way. If let's say you do have authority to get that data, that is wonderful. Okay, if on social media you need to have ethical issues, concerns relating to it.
Mm-hmm.
And once you have your data set, okay, you need to do sampling. You need to sample, because when you're doing training set, okay, it is about not just getting the numbers right, okay, a lot of number. You are actually wanting to get the corner cases, which is the unique cases that is going to represent the data set. Okay, so
okay.
Okay. So for example, if you're doing on cancer, you want to be able to have in your training set examples of cancer on eyes, on blood, on ovary, on breast, on whatever else. Because if let's say in your training set you do not have one of these cases, it means that your machine learning or your robot baby will not be able to identify. Okay, so what's important is to have a lot of data, because then the robot baby can learn. But more importantly is to have different cases within your training set that represents the actual population or the data set.
Okay. Okay.
Have I answered the question?
Yes. Can I ask more specifically?
Okay, sure.
Sorry, Mr. Ray. More time. Let's say we are going to make machine learning for defect detection on fruit or vegetables. We have limited data on the quality grading of the specific fruit. Can we just use range and generate that big data from this range that we already have? So it's not an actual experimented data, but we have the range, and then we use it to generate big from it. Can we do that will it be accurate?
Okay, so if let's say, so for me, okay, if let's say you are very confident that you have all the range, okay, which means that all the possible examples,
yes,
as far as you are concerned, you may have more in the future, but as far as you as a researcher, this is the most that I know, okay, what you can do is to use SMOTE, SMOTE. Okay, if let's say your your positive class, okay, your positive class, the one that you're interested to know in, is very, very small, right? Because that's an imbalanced data set. So when an imbalanced data set, you need to do either oversampling or undersampling. So usually if it is very, very small, you are going to upsample it. So you can use SMOTE, SMOTE.
Okay. Okay, noted. Thank you very much, Ms. Ruhaila. Thank
Okay.
you, Mr. Ray.
Right, so probably you can always ask Dr. Ruhaila about the details. You can always contact her on the following information that we have on the screen right now. Right, so probably we have the last question right here, and Dr. Ruhaila, probably you can just list out the technique for the forecasting by using image datasets. Probably just list it out. There's no need for further information.
List out for, sorry, for what just now? Is it
The
for?
best technique for forecasting by using image datasets.
Okay. So for image, it is any kind of machine learning steps will be based on the CRISP DM, CRISP data mining, okay, methodology. It means that you have to do the extraction of the data, okay, meaning that you need to have your image data set, and then after that you need to extract from it, okay, your training set that you think this is going to represent your population or your data set. And because it's images, you need to extract features from it. So the kind of features for image is different from textual. Okay, you may need to get the pixels, okay, the pixels, and then the difference in the tone of the color, okay. So some color, some red is more darker than another. So because you want to extract the objects, okay, inside the image, and of course you need to be able to map the contour. Like for example, if you're doing facial as the image, you need to identify, okay, to map out the contour from this, you know, this length, from this to this, and from here to here, okay, because people just can't change, you know, the width of their eyes, right? So, and then the nose, okay. So if let's say they're smiling, so it's like you have to have the contour for each part of the face. If you're doing facial, if you're doing for cats, for example, or for animals, then you need to be able to contour. You need to map the contour of the object of the cat. So once you get that feature, from that feature is the one that you're going to train your machine learning algorithm. So whenever machine learning algorithms see pretty much the contour is kind of like that, okay, then it will detect that that is a cat or a dog or a horse. So usually people would use TensorFlow for image processing, okay, or image identification or classification. So I hope that answers it.
Right, so that is all the time that we have for the question and answer session for Dr. Ruhaila. Thank you very much, Doctor.
Thank you.
So without further ado, let's proceed to our final speaker, fourth speaker, Dr. Romadhony, on her selected topic. Please welcome Doctor.
Yes, thank you very much. I want to share my screen. Okay.
Right, Doctor, we can see it clearly.
Okay. Thank you. Okay, can you see clearly? Okay, thank you very much. Can you see it clearly?
Yeah, Doctor.
Yes, okay.
We can see it.
Okay, good morning, everyone. Thank you very much for the opportunity. Assalamualaikum warahmatullahi wabarakatuh. Thank you very much for the opportunity to join in this international webinar jointly organized by Applied Computing and Technology Research Group, UiTM, and also side research group from Telkom School of Computing, Telkom University. Today, I will present a topic on NLP and machine learning, specifically on NLP for low or under-resourced languages. Okay, here is a brief intro of myself. My name is Romadhony. I'm a lecturer in School of Computing, Telkom University. I'm a member of Intelligent Computing and Multimedia Research Group, and my research interests are natural language processing, especially on low resource language technology and also text mining and information extraction. And since nowadays most of the natural language processing methods are using machine learning, of course I also interested on machine learning. And about current research or project that I do currently is on aspect-based review summarization and also on Indonesian dependency parsing. As for community service, I'm actively involved in Masyarakat Linguistik Computational Indonesia, or MALKIN, or Indonesian Association for Computational Linguistics. Okay. And actually for today's talk, I use these references as the main sources. So the first one is an article by Sebastian Ruders about why you should do NLP beyond English, and also the multilingual NLP that delivered by Yulia Sveskov on CMU Low Resource Language Bootcamp, and a lecture by Adi Guna Kunchoro on MLSS Indonesia that held on last August. Okay.
Doctor, can I interrupt?
Yes.
There is the audience right here said that the screen that they're sharing is not the full mod screen.
Not full screen?
Yeah, yeah.
Okay. Let me check. Okay. 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 Let me check here. Oh. Share screen. Okay. Is it okay?
It's just the same as previously.
Okay. I think it's about the screen resolution. Okay, let me check. Stop share. Excuse me. Apologize for this. Is it okay?
There is anyone from the previous speaker who could help Dr. Ading to set up the screen first, because the slide that we're seeing right now is just the same as previously. This is the slide that shows the current slide and the next slide, not the full screen. Is there anything that we can do, Dr. Warih?
No. Okay. Okay. I'm sorry. Okay, let me try again. Okay, is it okay?
Yeah, it's
Yeah.
okay.
I'm sorry for this problem. Okay.
Thank you very much.
Okay, let us continue to the outline of this talk. First, I will introduce, give a brief intro on NLP and machine learning, and then move to motivation of NLP for low resource languages and approaches on low resource languages. And at the end, I will explain some of the open problems. So the first is about definition of NLP. So some of the researchers mentioned that NLP is a set of methods of making human language accessible to computers. And also a researcher also mentioned that NLP is a set of methods for solving practical problems involving language. But there is also a new definition that involve artificial intelligence on the definition of NLP. And how about the difference between NLP and computational linguistics, since two of the terminologies usually used by the people interchangeably? Because when we talk about NLP, sometimes we also refer to the computational linguistics. So the difference between computational linguistics and NLP is on computational linguistics, this on language is the subject of the study. And in computational linguistics is play very important role. And we can also see the difference between computational linguistics and NLP from the goal. So the problem example on computational linguistics is how do we understand language, how do we produce language, how do we learn language, and the problems in NLP is more about applications. And I will not going to have to explain more about machine learning since Dr. Ruhaila already explained about it. So what is machine learning? So this is a definition by Tom Mitchell, and also we can see here that machine learning is subset of artificial intelligence, and nowadays the term also that very popular is deep learning since 2010. Okay. And first, we will see several NLP applications. The first one is machine translation. This is actually when I ask my students about what is the most frequent NLP application that you use, some of them answer that they use machine translation like on daily basis, since especially when they need to read a scientific paper or they need to read the book that is written in English. This is an example of a translation from Indonesian language to Malay language. Although the two languages have some words in common, but of course there is some of differences that can affect the semantic or the meaning of the whole sentences. Next, about an NLP application is question answering. So this is some of the demo from Ellen NLP when we have a passage or a that consists of several sentences, and then we have a question, and the question answer system will try to retrieve the correct answer for the question. The difference between information retrieval and question answering system lies on the exact answer. If we use an information retrieval system and the answer is on the form of document. Although nowadays we can supply the search engine like Google in the form of a question, and the machine will give us the exact answer also. You can try to use Google as a question answering machine also. The next application is also very popular, sentiment analysis, and this task is already explained by Dr. Warih. So given a text, and then the system will give a class, will result in a class. So for example, there is a review, and then the result is one of the class, whether the sentence contain positive or negative or neutral sentiment. Okay, so we can see some of the NLP applications on daily basis, and all of the application actually built on top of NLP core technologies such as language modeling, part of speech tagging, syntactic parsing, word sense disambiguation, name entity recognition, and some other core technologies. The first one, language modeling, the goal of the language modeling is to predict the next word occurrence given some of previous words. And the part of speech tagging goal is to produce the part of speech of the word class given a sequence of words. And syntactic parsing is the goal is to produce a tree or a structure from a given sentence. And when we try to examine the meaning of the word, we can use word sense disambiguations, since one word can have more than one sense or meaning. And name entity recognition usually involve in information extraction. The task is to extract structured information from unstructured or from free text. Okay. And the method that involved in natural language processing with machine learning approach can be divided to, generally can be divided to two types. The first one is supervised and the second one is unsupervised. Dr. Ruhaila also already explained about it. So supervised means that we have labels, and the unsupervised approach is the opposite. So we do not have labels. So instead we want to try to group and analyze the structures. In the middle of supervised and unsupervised is we can do a semi-supervised when we only have a little or a few sentences or a few texts as a data set, but we want to add the data label data set automatically. We can use the semi-supervised approach. Okay, so now we're gonna see what some of the NLP problems that frame as supervised learning problems. So generally on supervised learning problems, we have two notations. The first one is for the input, we use X, and the second one is for the output, the notation is Y. So the input is the text, and the Y or the label, it depends on the task. For examples, on the post-tagging task, the input is sequence of words in a sentence, and the output is the sequence of part of speeches. So, for example, I want to go school. So, what is the part of speech of the word I? What is the part of speech of the word one, etc. And the next example is on sentiment analysis. So, the goal of the task is to predict the sentiment class or the label. The label can be positive, negative, and or neutral. So some system use two classes, some other sentiment analysis use three labels. And what about the machine translation task? In machine translation task, the input is the text in the source language, and the output, or Y, is text in target language. So if we want to solve this task as a supervised learning approach, so we need to have labels or the Y in the data set. And about the unsupervised learning approach, the motivation is because building label dataset is very expensive and difficult. So we need the expert to do the label, and it is also require much of time. So this is very expensive. And currently, since we are live in the internet era, and then actually we have a lot of unlabeled data, and we can benefit from those large unlabeled data. So this is the motivation of the currently hot topic, pre-trained language model. And the pre-trained language model achieves the state-of-the-art on downstream application, especially on natural language understanding topics. Okay, so why the task in NLP is hard? Because in NLP, there are some challenges from ambiguity, scale, sparsity, variation, expressivity, unmodeled variables, and unknown representation. So how to represent the word and also the meaning is also a quite big topic in NLP. Okay, and why I choose the topic of machine learning and NLP, because if we look at the history of NLP, actually the field already become an active topic since 1950, but on early days, the method used is rule-based method. And then since the data set is become bigger, so the statistical based method give a better result. And also the statistical based method outperform the rule-based method. And from the 2010s, the deep learning based approach dominate the approach on NLP. And this is also an important thing that we can see from the current development of NLP. Nowadays, the NLP goals is oriented towards machine learning rather than linguistics. So this is also an interesting point. Okay. The development of the NLP research based on machine learning methods also can be seen from the publications on top NLP conference. So this is from papers from ACL conference. So we can see from year to year, the paper with the title Neural is become more popular. And we can see there that the neural net approach is like most popular method since it gives best performance between some of other methods. Okay, so that's about the NLP and machine learning. So now about the low or under-resourced language. So why on the recent, maybe last 1 or 2 years, some of the researchers on NLP put focus on low or under-resourced language. Since based on the data from Ethnologue, if we see the linguistic diversity, not all of the top most spoken language in the world has sufficient resource. Since resources is very important on machine learning based approach, of course, this thing is very important to be considered as the new research direction. So for example, in this data set, Indonesian is included in the top 10 most spoken language in the world. And this is the result of the research from Josie et al. They classified the language resource distribution between all of the language in the world, and they divided the language classes into 6 classes. And we can see in the diagram that most of the languages in the world belong to the class 0, the left behind. It means that in this class, there is almost no language resource found for the languages. Bahasa Indonesia or Indonesian language belongs to the class 3, the rising stars. So actually, there are not so low or not so little language resources for Bahasa Indonesia, but researchers mentioned that should collect many sources. And since some of the current or state-of-the-art methods rely on deep learning-based method, of course, this make a comment from any researchers on NLP. The methods work well only when large amounts of labeled and unlabeled data are available. Refer to English. Okay, so there is some research that prove about this statement. And yeah, since so this is not always true if we say that this method has best performance of this task, since actually not of the state-of-the-art research performed in language other than English. And so what is actually low resource language? This is from Yulia Setskov definition. Low resource language means that a language that has no large monolingual or parallel corpora, and or manually crafted linguistic resources. This becomes a problem when we have to build a statistical NLP tools. Of course, this is very difficult to build a statistical based NLP tools if we don't have a label or maybe only monolingual dataset. And what is the motivation to work on low resource language? Because we can see some of the important applications like disaster or emergency response application in Indonesia, or we know that this country has many experience on natural disasters, and sometimes the user, the people in Indonesia use social media to give a response. If we don't have an automatic response application, and then some of the effect of the disaster can be handled in a quick time. Another application is on education application. So this is not fair to force all of the people in the world to learn in English, because actually all of the language is equally important. And then translation system, and also we need to documenting the cultural history. And since some methods has best performance on English language, how about applying standard methods on high resource language to low resource language? I already mentioned that the state-of-the-art methods or NLP models require very large data sets. And we can see here some of the training data available on the low or under-resourced language is not comparable to the size of English dataset. And how to do NLP for low resource language, we can see from the two perspectives. The first one is by doing resource checking, and the second one is there are several approaches that we can implement for low resource NLP. The first one, the guideline on resource checking, I refer to Yulia Setskov. And the second one, several approaches for low resource NLP, I refer to Adiguna Kunchoro. Okay, the first one on resource checking. So if you want to do NLP on low or under resource language, so the first one you need to check is whether there are sufficient training data for the task. If there are sufficient training data, and we can do supervised techniques. If not, and then we should check whether any relevant training data from other languages. If yes, and then we can build cross-lingual bridge. And if there is no, we should check the monolingual corpora. And there are two options if there are two monolingual corpora. The first one is use unsupervised or semi-supervised technique. And the second one is to annotate the data. Okay. And about the approach to low resource NLP, there are some approach that we can implement. The first one is by performing simple translation. So this is simply to translate from one document or one text or one sentence to the other documents. The second one is to do lexicalization through universal post-text. So instead of simply translate from one word to another, we go to the more general form that is part of speech tagging. So we use the part of speech tagging label to perform the task. The pros of this approach is simple to do. So in some language, the performance of post tagger is already quite good, and the cons is not suitable for some tasks. For example, on sentiment analysis, the words level still play an important role on determining the sentiment. The next approach is by using cross-lingual embedding. So the idea of this cross-lingual embedding is we have two word embedded into languages, and we try to map between those languages. It means that at the end, we will have a mapping between those two languages, and we can use the cross-lingual embeddings as input for the downstream applications. Usually, this approach works better than post-text delexicalization. But the cons is this model could not accommodate different word orders on different languages. So there are some languages that has different subject, object, verb orders. And the last approach that we can do is by using cross-lingual contextual representation. So the motivation is based on the current state of the art pre-trained embedding, BERT. So the difference between BERT and the previous embedding is BERT is a contextual embedding approach, means that we can model a word that has different senses as a different embedding. And BERT is really successful in monolingual setting. So on cross-lingual contextual representation, we try to extend the advantage of BERT monolingual setting. And on a multilingual BERT, the process consists of several processes, starting by concatenate the monolingual corpora. So basically, it needs a monolingual corpora from all the language that we need to model. And then the process of learning sub-word dictionary are performed jointly. And then the pre-training on the multilingual corpora. And then the next step, fine-tune the pre-trained BERT model on the task on a high resource language. And the last step is to apply the fine-tuned multilingual model BERT on the low resource language. And what is the pros and cons of the approach based on cross-lingual contextual representation? So the pros is this approach, the performance is surprisingly well. So there is one research by Konrad Juk that they built a universal dependencies parsing by only using one model. So they built only one model and they produce 75 dependency parsing for the 75 languages. And multilingual BERT also available, and we can use it, the pre-trained multilingual BERT in approximately 100 languages, and the performance usually work better than cross-lingual embedding approach since it contains sense information. But there are also some cons of this approach, like the approach is less straightforward, and also we need to consider the computational cost and also about the generalization, and also some issues with the specific language properties like tokenization issue. Okay, so based on the several approaches that we can do for NLP for low or under-resourced languages, so actually this is still an active research problem since there is no one size fits all best approach. So if somebody said that this is the best approach for tackling a task, and then the claim is can be used as the best approach or the best model. And we also need to realize that the approach is better for low resource languages that are more similar to the high resource language. So also there is some study that map the correlation between the language type on high resource language to the low resource languages. And also we need to consider that it is not always easy to obtain clean and large data set. So most of the language in the world has no clean and large data set. And also we need to consider the domain shift. So an application in one domain can be guaranteed to have also a good performance on another domain. And speaking about the percentage, actually most of the approaches only really applicable to about less than 2% of the languages in the world. Okay, this is the last of my talk. This is not about the technical, but this is the recent research that I want to highlight, that on doing NLP for low resource languages, it needs a collaboration. For example, several weeks ago, some of our college released IndoBird and also IndoBenchmark.com. So this project is involves several people from different institutions. You can check the benchmark and also the language model here in this website. Also, I see the Masakani project in Africa that they built an LNP project for Africans by Africans. Okay, thank you very much for your attention. I will happily see if there is any question. Thank you.
All right, thank you very much, Dr. Ade. So now it's time for the question and answer session for our fourth topic, fourth speaker. So we have a question right here, Doctor, on the chat box.
Yeah.
So maybe I can read it for you.
Okay, okay.
Okay.
I'm sorry, I stopped the stream sharing.
All right, it's okay. Assalamualaikum, Doctor. I'm Nurul from
Natalia.
Yes. My question is that the research of NLP is expensive.
Okay.
And it uses a lot of computer resources, which also need to be scaled based on dataset size. And is there any services that provide us resources for the research instead of buying it? Thank you.
Okay, thank you very much for the question, Nurul Natalia. So actually there are some free or publicly available dataset that we can use. For example, of universal post-tag and universal dependency, you can access it in the universal dependency website. Okay, I will give the link. I already give the link on the slide. Okay.
Right, so as the
there are publicly available dataset. Okay.
All right. Okay, so I hope that is answering the question from Natalia. Is there any more?
Okay. For example, another example is on WordNet. Okay, there is one WordNet for Malay, bahasa Malay. For bahasa Malay already accessible. I think it's already developed by some researchers from Singapore, if I'm not mistaken. Okay. For other dataset, I think you can also search based on ASEAN project. ASEAN project already from in the cooperation with NICT, they release a dataset in the ASEAN countries, text in ASEAN countries. Okay, I will check. Where's the universal dependency post-tag? So yeah, you can go to this website, universaldependencies.org, and see whether there are dependency on the particular language that you want to work on.
Right, so I'm a bit curious about the computer resources that we need to use, because NLP, as I understood, it is a machine learning research, right? In machine learning research, we use a lot of computing powers. These computing powers is expensive, right?
Okay.
If you don't have enough money, maybe we can rent it from somewhere.
For the computing resources, of course, this is also one of the challenges that the researchers on low or under-resourced language have to face. But yeah, nowadays we can use pre-trained language model. For example, the multilingual BERT, are actually in some tasks. Sometimes we don't need to perform the highly intensive computation. For example, when we perform like a sentiment analysis or maybe for post tagging, on post tagging, some of the post tagger in several languages, the post tagger already has an accuracy for about above 90% by only using like 1,000 label sentence. Yeah. So it also depends on the task, and you can follow the direction here about the resource. Of course, we need to adjust our goal to the availability of the resource. For example, if we want to build the similar BERT model, like the English model, it will require maybe some days, like more than 3 days, for example. And if we want to build our own, so we need to consider our computing resources. The Indo-BERT model, they mentioned in the paper that they need like so they conducted in 2 phases. The first phase is like 30 plus hours, and the second phase they need 20 some hours. So they also consider the computing resources. Yeah.
All right, so thank you for the answer, Doctor. So probably we have a few minutes. Last question for here. Is it possible to find word order of a low income, low resource language in Arabic like script using lexical networks with labeling? The question is available on the chat box, Doctor.
Okay, the word label on to find word order of a low resource language in Arabic like script using lexical network. So yeah, thank you for the question, Nuzat. So if we use a contextual language modeling method like BERT, so it is possible. So actually the language model approach is we don't have to, there is no requirement to have a label since the text itself is contain the label. Okay. Yeah.
Right. So I hope
Yeah.
answer from Dr. Ade.
Yeah.
Question right here.
Yeah. There is one suggestion from Mr. Surya Agustian. Thank you. You can try Google Cloud, Microsoft Azure, or Amazon AWS. Okay, if your institution has access to Microsoft Azure or Amazon AWS, it will be a good start. But if you don't have, and then you can try Google Colab. For example, if you use a PyTorch library, you can run your script on GPU. So I think most of the model available nowadays can be executed in Google Colab also.
All right, thank you very much, Dr. Ade. So that is all the time that we have for the question and answer session, and that is the last speaker that we have for today. With that, ladies and gentlemen, we have reached to the end of the event. We hope that the attendees gain benefits from the talks delivered by our expert speakers today. And I think you can always contact the speakers that we have today, the 4 speakers, expert speakers, to ask them any question regarding the topics that they have delivered today. And on behalf of the organizing committee, Advanced Computing Research Group, UiTM Perlis, and Telkom University, Indonesia, I would like to express our gratitude to our expert speakers and to the attendees who attended and willing to spend your time with us. As the webinar is a planned series, we will try to bring more interesting topics in the series, and we hope to see you again soon. Again, thank you very much for your participation, and hopefully we will see you again in the next series. Thank you very much.
Thank you very
So,
much. Thank you.
before we end the event, I would like to ask all of the attendees to turn on their camera for so that we can see your faces, right? The attendees. We'd like to take a picture to commemorate and as memory for us in today's event. Please turn on your camera so that we can take screenshots. Thank you very much. Right, let's wait a bit. Please, the secretary, let's take picture. Right, I think that, is it okay already? Okay, all right. So I think that is all for the events today. Again, thank you very much for attending and participating our events, and soon in the next series. And before we end our session, I would like to also remind about the attendance. We have already provided the link on the chat box. You guys can fill in the form so that you can get an electronic certificate in your email later on. All right, thank you very much and see you again soon. Assalamualaikum warahmatullahi wabarakatuh.
Alright. Dr. Dana ada di dalam ni, Ibu Warih?
Ada. Ada, tapi tadi paralel mengajar.
Oh, okay. So next, so next Telkom University yang anjurkanlah Ibu Warih ya?
Siap, bulan depan ya?
Boleh.
Ya.
Cuma sirinya apa?
Nah, saya discuss dulu dengan teman-teman.
Oke, nanti diberitahu lah. Oke.
Yep.
Nanti
Udah
kami...
left lu.
Oke, left.